Atom Builder, we can look at several different visualizations of protons, neutrons, and electrons in an atom. We can choose any atom on the periodic table, and it sets to default to go to one of those particular isotope of that atom. So every atom is made up of neutrons, protons, and electrons. We have that visualization here of those particle counts. We have a visualization above in Atom Trinket above the desktop, where the protons and and neutrons are found in the nucleus, and the electrons which surround the atom are found outside of the nucleus. This is not to scale. We know as chemists that the nucleus is very, very small, about 1,000 times smaller than the space that the electrons take up. But the neutrons and the protons weigh a lot more, and they weigh 1. So we have the atomic number, which is always corresponds to the element. So whenever you have an atomic number of 16, you have the element sulfur, but it has different isotopes, meaning it has different numbers of neutrons in the nucleus, and we can watch and add a neutron to the nucleus, and we see that the atomic mass changes. That means they're both equivalent to 1. So for every proton and neutron, total is the atomic mass of the element. So those are represented in many ways by chemists. We represent them in this tile view very often, where we show the atomic number and the atomic mass of an isotope. We also list the chemical name and the chemical symbol. Over here we can see what you might see on a typical periodic table, where you have, here's the atomic number, here's this name and the element symbol, and here's the accepted atomic mass, which is actually a weighted average of all the natural abundance of the isotopes. So then we also show are able to show the electrons in different visual representations. We show it in the atom trinket here, and we're going to zoom in here on our atom trinket and look at the electrons of the element. There are always the same in a neutral atom, the same number of electrons as there are protons. So we have 16 electrons shown outside here, and this is a second layer up to 18 electrons in a third and fourth and above layers. So that's represented there. We also represent the electrons in electron diagram, where the energy of the orbitals that the electrons fill increases, and it keeps filling those orbitals until 16 electrons total have been reached. You'll note that we note the valence electrons by underlining in this white color the 2 valence shell electrons that or orbitals that are available, the 3s and 3p. Also on so right now we're showing sulfur 30 with a atomic mass of 32, but you could add more protons and have an atomic mass of 36. Another thing we can show here is we can add and remove protons or electrons. So if we do that, we can get different ions of sulfur. The accepted common ion is -2. We can also refer to this as an oxidation state, and there are other oxidation states of sulfur, but sulfur 2- is the only ion found in solution by itself. So the other oxidation states are usually generally found in molecules that contain sulfur. Let's see. Finally, we can, okay, if we, now let's go back to, if we change the number of protons, we notice we're actually changing the chemical. If we add neutrons, we're changing the isotope. Argon doesn't have any ions, so let's go to magnesium. And if we subtract electrons, we get to various ions of magnesium. And we allow the learner to play and make ions and molecule or atoms that do not exist, but when they get to an atom or ion that exists, you through learning a particular idea in what we call sessions, and you can see this is Intro to Atom Builder, which has which will tell you about the various features that I've gone through in Atom Builder. But we could actually also guide a student through learning about the electron configuration diagram or isotopes themselves. We could tell them to add neutrons and see that they're going to change the isotope. We could tell them to add protons, and they will learn that whenever they add or subtract protons, they're going to change the element. And then we can guide them through adding and subtracting electrons, and they'll see that they're going to change the charge of the element because the number of protons and electrons no longer equal one another. Whenever the protons and electrons equal one another, that's usually the elemental form and an oxidation state of 0.